So welcome once again to our series. So moving ahead to the next question related to theory of equations. So that's again a special one, bachcho. That's again a special question. Okay, where we'll be looking at some concept of functions also. Okay, so let's start. Find real roots of the equation when a is given to be between 0 to 1/4. We have to solve this equation for a between 0 to 1/4. See the idea. How come I get the idea of whatever I am going to discuss here? So the idea came from the fact that this is square, a quadratic in x, whereas this is square root of x. Okay, so one side you have a quadratic and one side you have square root of x. So the very first thing I started it, and see, and again, how and why can I use it? Because I have that statement always in my at the back of my mind, and it says if we have to solve a equation that is fx function is equal to f inverse of x, inverse of it function, then this is equivalent to solving fx is equal to x, or f inverse x is equal to x. And why so? See, we know from the property of the inverse function that a function, the curve of a function and its inverse are mirror images on the line y is equal to x. So they are mirror images on the line y is equal to x. So where does the object and image meet? So they can meet an object and image. So if that's the curve for y is equal to fx, also assuming it to be a 1, 1 function, so in that case its mirror image on this will be y is equal to f inverse x. So again I am repeating my question, when will object and image meet? They can meet only when they lie on the mirror. Okay, so number of points of intersection of the object curve and the image curve will be same as the number of points of intersection of the object and the mirror. So that's why I said solving this is equivalent to this or this, until unless there is an identity statement type of thing. We have an exception also. We can have many such exceptions, but a simple one is if you have a curve, like you consider a line which is perpendicular to the mirror. Okay, so when you take its mirror image, it's going to be the same. So fx is equal to f inverse x. The function itself is a self-inverse. You have infinite solution, whereas the object meet the mirror only at one point. So if you solve this object fx with x, you will get only one solution, whereas fx is equal to f inverse x has infinite many solution. Okay, so it has exception, but of course exceptions are exceptions only. Okay, we need to remember the general statement, so that's quite useful one. Now to start with, I will say x square plus 2ax plus, I think, what was that, plus 1/16. So it's plus 1/16. So that's our function, let's say, and we have to find its inverse. But before trying to find the inverse, we should take care of the fact that whether the function is a 1, 1 onto function. So onto is not a problem because there is no codomain given, but it has to be a 1, 1 function. Okay, where will we be using it, I will tell you later. But see, it's an open upward quadratic. It can't be a 1, 1 function. And the vertex is at x is equal to minus b/2a. So at x is equal to minus a, you have its vertex. So either function is 1, 1 on the left side of minus a, or it is 1, 1 on the right side of minus a. Okay, so when we will be writing its inverse, we will take care about the inverse depending on which side of minus a are we talking about. Okay, now let's start. So y is equal to x square plus 2ax plus 1/16. Now we know how to find inverse. We will treat it as a simple equation in x and try to get x in terms of y. So you have to just find x using this equation. So you can apply Sridhar formula, take it to the right side, y and equal to 0. So you apply Sridhar formula for x and you get x in terms of y. But we can do it otherwise also. I mean, Sridhar formula is also based on this the same concept, completing the square concept. Okay, so you have y plus a square minus 1/16 is equal to x plus a whole square. So you get x from here, and what is it? So x is equal to minus a plus minus under root of y plus a square minus 1 by 16. Now again, one more statement, inverse of a function is always unique. You can't have two inverse here, you got 2x here, not possible at all. Which x to choose? Square root can never give us negative value, so square root is always positive. So that x value which we depends on the domain to make it 1 1 function. So if x is less than minus a, then shall I write it? Let me. If x is less than minus a, so that means I will choose this to be the x here. Of course, in that case only it is less than minus a. Or if x is greater than minus a, so we will choose it as minus a plus under root of y plus a square minus 1 by 16. Okay, now which one we have? So let's go back to the question. Minus a plus a square plus x minus 1 by root. So minus a plus, so that means we are here, bachcho. Okay, so that's the condition which we need. So therefore x is minus a plus under root of y plus a square minus 1 by 16. Now to get inverse, you need to interchange the position of y and x. So wherever you have y, you will replace it with the x, and of course you have x at only one place, so that means f inverse x. So wherever you have y, just replace it with x, and that's it. So the RHS is the inverse of LHS. So therefore, as I said, we'll be solving this equation x square plus 2ax, I think it was plus 1 by 16, yeah, is equal to x when x is greater than minus a. That's it. That's it. So now you can apply Sridhar formula, that x, that a will be of that x will be useful for us which is greater than minus a, and remember that a lie in the interval 0 to 1 by 4 if I am not wrong here. Okay, so a lie in the interval 0 to 1 by 4. So see, now you got a simple quadratic in x. We can apply Sridhar formula and then solve it. So the concept behind this question was that if this is my function, this is our f inverse x, and see, you can this idea can strike your mind only when you have this statement with you. When you have this statement with you. So if you have this statement, you remember this statement, this idea may strike your mind, and now once you know it, you should always remember it, bachcho. So okay, so that was the question for theory of equation for today, bachcho.